Okay, so when we're talking about transformations of functions, we don't need to make a table of values. We don't need to graph this whole um, function here. What we need to do is we need to remember this table. So this table looks at all the different transformations that we have. So we can shift up or down, we can shift left or right, we can mirror the image of the graph along the x-axis, we can mirror it along the y-axis, we can stretch it, and we can shrink it. It looks like a daunting task to memorize this table. It's not bad, again, because they go in pairs. And it's one of those things where the more practice you get with actually transforming these different functions, the easier it will be to memorize these patterns. So let's take a look at this function here, which says f of x is equal to x minus 3 squared plus 2. So if we want to graph this, let's first think of what the parent function is. The parent function is x squared, and y is equal to x squared. We know that because for this new function, the power is 2, so it's also a quadratic, which means that it's going to be a parabola. Every parabola looks just like the parent function parabola, which is just a simple x squared. Now, for this, hopefully we know some of the points to make the graph, but if we don't, we can make a table of values. But when x is 0, y is 0. When x is 1, y is 1. And when x is 2, y is 4. When x is 3, y is 2, 4, 6, 8, 9. And everything is just mirrored on the opposite side of the y-axis. So we have this nice parabola. Now, as we graph this, we don't care too much about the lines. Don't focus on the graph of the function itself, so to speak. Focus on the points. And what we're going to do is we're going to shift all these points based off of this. So if we look here, we have an x value minus 3. Going back to this table, whenever we have the minus 3 next to the x, or we're changing right next to the x, that means we're going to shift to the right that amount of spaces. So here, this is minus 3. So we're going to shift each point to the right 3. So shift right 3. With this 2, that's being added on after the function. That means we're going to shift up c spaces. So here, we're going to shift up 2 spaces. So for each of these points, almost like when we were drawing a line and we looked at rise over run, or the slope, for each of these points, we're going to shift it and move it to the right 3 and up 2. So here, from this point to the right 3 and up 2 is going to be there. This point, if I move it to the right 3, 1, 2, 3, and then up 2, it's going to be there. This point to the right 3, and then up 2. This point to the right 3, up 2. This point to the right 3, and up 2. This point to the right 3, 1, 2, 3, up 2. And now you can actually see that parabola being formed. 1, 2, 1, 2, 3, 1, 2. And so now when I draw and connect the dots here, through my crude handwriting, you can see it looks just like we took this parabola and just shifted it. That's all we need to do with this. So the hard part shouldn't be making a table of values, multiplying this out, finding x, or thinking of an x and finding the y value. That's not the point with this. The point is knowing this table and how these transformations take place.